this class we are going to see effectiveness of parallel and counter flow heat exchanger. The aim of this experiment is to determine effectiveness of parallel flow and counter flow heat exchanger. First, what is meant by heat exchanger is it's a device which is used for converting heat energy from hot fluid to cold fluid. So here we are having parallel flow and counter flow heat exchangers. So what is meant by parallel flow heat exchanger is you will be having two fluids. One is hot fluid and another one is cold fluid. So if it travels in same direction, so then that is called as parallel flow heat exchanger. Whereas in case of counter flow heat exchangers, here also you will be having two fluids, so which travels in opposite directions to each other. So then that is called as counter flow heat exchanger. So considering inner tube hot fluid is flowing inside, which is having an inlet temperature of Thi and outlet temperature of Th0, and for cold fluid which is flowing on the outer tube, so which is having inlet temperature Tca and outlet temperature Tc0. Similarly, for counter flow heat exchangers, hot fluid travels in the inner tube, cold fluid on the outer tube, but the flow direction is in opposite direction. So hence it is called as counter flow. Here it's inlet temperature Thi, Th0. For cold fluid, this is the inlet temperature, that is Tca and Tc0. So in this experiment we are going to determine effectiveness. So its formula is Q average divided by C minimum into Thi minus Tca. So same formula is for counter flow heat exchanger also. So here we are going to consider for hot fluid, we need to find mass flow rate, as well as for cold fluid we need to find mass flow rate of cold fluid. So T1 represents temperature of hot fluid, inlet temperature of hot fluid. T2 is exit temperature of hot fluid. So whereas T3 represents inlet temperature of cold fluid, T4 represents outlet temperature of cold fluid. Similarly, for counter flow heat exchanger, we need to find mH and mc, which is mass flow rate. So T1 is inlet temperature of hot fluid, T2 is outlet temperature of hot fluid. So whereas in case of cold fluid, so T3 represents the outlet temperature, T4 represents the inlet temperature, because the flow direction reverses in this case. So for calculating effectiveness, first we need to find Q average. So Q average can be calculated by QH plus QC divided by 2. So what is QH is mH CPH into capital T1 minus capital T2, which is for hot fluid. So what is the mass flow rate of hot fluid? Specific heat of hot fluid, inlet temperature of hot fluid minus outlet temperature of hot fluid. So this represents QH. QC is MC CPC into T4 minus T3. So which is mass flow rate of cold fluid, specific heat of cold fluid. This is the exit temperature and inlet temperatures respectively for cold fluid. So mH mass flow rate, mc is mass flow rate of cold fluid, CPH and CPC are specific heat values. So here we are using only water. So hot fluid is also water and cold fluid is also water. So its value is constant, which is 4.186 kilojoules per kilogram Kelvin. So next, in order to determine C minimum, we are going to find the specific heat capacity value. CH is mH CPH, CC is MC CPC. So now we are going to compare these two values. In these two values, which is having minimum, so that value can be taken as C minimum. You have to substitute here. So THI is inlet temperature of hot fluid, TCA is inlet temperature of cold fluid. If you substitute, you will get the value of effectiveness. So this is the experimental setup for our parallel flow and counter flow heat exchanger. So here we are having a heater for producing hot water exchanger. So as we have already seen, so inside inner tube hot fluid is flowing through it, on the outer side the cold fluid is flowing, so which will be in same direction. Hence it is called as parallel flow heat exchangers. So here they have given. So T1 is the hot water inlet temperature, T2 hot water outlet temperature, T3 cold water inlet temperature, and T4 is cold water outlet temperatures. So these are the specifications. So inside this we are having a copper tube, so where its inner diameter is 12 mm and its outer diameter is 15 mm. Outer tube is galvanized iron tube, so which is having a diameter of 40 mm. So for parallel flow heat exchangers, inlet and outlet temperatures are capital T1 and capital T2 for hot fluid, and inlet and outlet temperatures are T3 and T4 for cold fluid. So whereas in case of counter flow heat exchanger, it changes. So T3 is the cold water outlet temperature, T4 is the cold water inlet temperature. So remaining, as we have already seen, hot fluid flows in one direction, whereas cold fluid flows in the opposite direction. Hence it is called as counter flow heat exchangers. So initially we will have a valve here, so to open the water. So through this heater, we can maintain hot fluid. So hot fluid flows in this direction. So whereas in case of parallel flow heat exchanger, since water flows in this direction, hot fluid water flows in one direction. In the same direction, the parallel flow, cold fluid also will have to travel. So the water has to enter in this direction. So where we have two valves here. So this valve must be opened. So this valve must be closed for parallel flow. So if you open this valve, the water flows in this direction and it has to enter through this tube. So you have to close this valve also. So that water enters through this tube and flows in this direction. So hence it is called as parallel flow heat exchanger. So this is a measuring flask. So where you have to measure 1 liter of water collection. So you have to collect this water from both the tubes. So and you have to measure the time taken. So this is the mass flow rate. CP value for water is 4.186, it's same. So next is for counterflow heat exchanger. So water has to travel in the opposite direction of that hot fluid. So that in this case, so water coming in this direction, you have to open this valve. So this valve must be open, so whereas this valve must be closed. So that water enters through this direction, and the water has to come down. So that you have to close this valve. So that water enters here, and cold fluid travels in this direction. Hence it is called as counterflow heat exchanger. So you have to open this valve so that you can collect water, mass flow rate of water through this tube. So this is for counterflow heat exchangers. So remaining, we have to substitute the formulas and to get the effectiveness of heat exchangers. So this is the thermocouple values which have been indicated here. So T1 is the for parallel flow. I am saying this. So T1 is the hot water inlet temperature. T2 hot water outlet temperature. T3 cold water inlet temperature. T4 is cold water outlet temperature. So this is for parallel flow. So whereas in case of counter flow, capital T1. So this T1 is the hot fluid inlet temperature. T2 is hot fluid outlet temperature. T3 is cold fluid outlet temperature. T4 is cold fluid inlet temperature. This value alone changes because of direction changes. Cut பண்ணிடுறேன்.